discovered a lot of leftover MDF boards and other scrap pieces of wood in my shop. And I found that with all my miniature modeling projects, there's definitely one thing missing: a foam cutter. I'm not really big on post-roll and all those foam materials, but that has a reason. They are difficult to work on, especially with knives and saws. So I came up with an improvised challenge to build me a foam cutter from what I have, from scratch. And so all I had to buy for this project was the actual nichrome wire, which you can get for like $4 on Amazon or eBay. And everything else was just laying around from previous projects and from other discarded leftover things like shelves and such. Now this is not just a cutter, it is adjustable in the angle, has a fence, a rotating sled, adjustable temperature settings, and it runs on only 2 amps. And yes, it does work. It certainly does look like it didn't cost much, but the trial projects have been of tremendous quality, especially what you see in the end. And who cares what it looks like is when it gets the job done. So let's get started. I just cut off the rough edges of the base plate to eliminate any bumps or other surface impeding marks on the edges. And then I did something which is actually a bit risky, to mark the hole for the wire before everything else, because you cannot say for sure where your cantilever arm will end up. However, I designed it in a way that gives me the appropriate leeway in order to make any adjustments in the end. And so for this I took this little brass pipe and put in another brass pipe into it in order to have some insulation from the heat, and glued it together with this fire resistant glue, like so. And this way I wanted to make sure that the hot wire doesn't burn up the MDF plate or something like that. And so I filled the glue in there in order to have an even spreading around of the glue inside the larger tube. And yeah, once it was dry, I put it in place, and that was the mounting, or better yet, the guide hole for the wire to go in. Next up, the framework underneath the base plate. Strongly dependent on your power controller, obviously. Now this is a 2 amp fan controller, which was given to me or donated by a friend for my ROV projects, and it was just laying around because of the low amperage, but for this it was just perfect. And this thing regulates the power for the wire. Now the power intake plug was already fixed to it, and lazy as I was, I just went with it and took the cable that was in place and drilled the hole for the intake power plug just where it had to be. Widen it up a little bit so it's a nice snug fit. There. Then screwed it all together very carefully with pre-drilled holes, because these are right on the edge of the wood, so you have to be very careful not to put much tension onto the wood. Also another screw here to fix the intake plug into the hole, otherwise it would just slide in if you come with your power supply. And voila, that is in place. I deliberately left a 3 centimeter clearance between the base plate and the frame in order to be able to install the sled, clamps, or other devices which might be needed to achieve the desired level of accuracy when cutting. From my ROV projects, I had a leftover 12-volt LED, which I also installed here for a power indicator and also a vague voltage indicator. Now the maximum voltage is actually given by an adjustable 2 amp power supply, which is not shown here, where I can preset the voltage to 7.5 or 9 volts. So only the fine-tuning is done with the controller, and that way I can be sure not to exceed the maximum current of 2 amps. But more on that later, because it really depends on the length of the wire to have the right length with the right voltage and the right current. It's not that tricky as it sounds, really. And here I was just fiddling with a front plate in order to hide the electronics, in order to give it a little more even finish with the LED and also the control handle. Pretty easy. It was also a packaging from, I think, an IKEA cupboard or something. I don't know where I got this from, but it was just like 3 millimeters thick, and so it was pretty easy to get the controller in there and also the thread of the LED. This additional board serves as the foundation for the nichrome wire for one of the DC polarities. Of course, some of the cables have to run through it. The screw, which serves as a bearing for the nichrome wire, is slightly off to one side. That way it meets up with the head as a tangent. At times like these, you really wish you had a third arm. Here I soldered one of the cables to the metal washer, which leads power to the nichrome wire. And that is one part of the wiring. And here you can tell the alignment is just where it's supposed to be. Nice. As you can probably tell here by now, the alignment of the cantilever is everything. If it's off-center, you won't get a 90-degree angle for the wire. Of course, as said before, I have some leeway in the final assembly, but one prefers not to make too much use of it. Since at this point I was off by a few millimeters, I could cope with it by slightly over-bending the two cantilever crossbeams into place, fixing them with the screw, and that evened out the offset by a little bit. Now I clamp the whole thing together, making sure I have a steady distance to the base plate from start to finish, and fix it in place with some screws. Now, since it was rather unstable and shaky, I decided to install a knee brace, or strut, depending where you call home. And that really did the trick. And now, Feast your eyes on this alignment. Now this double cross construction is just screaming out to be used with a sliding sled. And the idea behind it is to have the nichrome wire installed here with the wire spool in place, and also to keep the wire tight at all times. It was a little bit of trial and error in order to make this whole thing work. And first I'm gonna show you how I installed the bearing for the nichrome wire, where it actually goes down to the base plate. Now this is why I never throw anything away. These are electric guitar string bullets. You can still see some of the leftover strings here on these bullets. They are made of brass, and I've kept these for years. I mean, I've stopped playing mostly in the last couple of years. I still do from time to time, so my supply has become limited, but these things are just the best. And a couple of other brass little pipes that I keep around from previous projects, install them together, and voila, this is a great electrical conductor with the nichrome wire bearing on one side, and also have a power intake on the other side, and that works quite well. As you can see here in the middle one, this is where the wire goes. If it's slightly off to the side, don't worry, you can bend it off to the side just a little bit, but in a nutshell, this is a perfect fit for the nichrome wire. Fix the whole thing in one place with the head of a nail. On the other side I just soldered it together, and it was finished. Boom. Now you might wonder why the top part, or the handle of the sled, is attached so asymmetrically or crooked. It's because I just used what I had laying around. And also it is important that the handle is right above the wire bearing. Otherwise, if the tension on the wire is too high, you could tip the sled, thereby losing the tension of the wire altogether. Here you can see the spool has found its place, and here to be installed yet another lamp terminal or lamp connection that serves as a guide for the wire from the spool down to the bearing. And here a third singular lamp connector with a spring. So what you do is you slide the wire through the connector with the spring tensioned, and then you screw the wire tight in the connector, and with that the tension of the spring is brought onto the wire, thereby pulling it nice and straight. Now it's time to attach the other polarity of the power source onto the other end of the wire, which of course means attaching the wire to the sled. Fortunately, I have this old discarded speaker cable laying around, which should work just fine. And to which connector does this cable go? Of course to the one with the guitar bullet bearings. That way the spool doesn't get any electricity. The power goes from the bearing straight into the wire. And here you can see the spring doing its thing, making the wire nice and straight. Perfect. Oh yeah, look at that. And finally, through careful measurements with my protractor, I marked all the significant angles and decimal steps from 90 to 45 degrees. Now, the laws of trigonometry state that a wire becomes longer when it is at an angle. I'm forming a hypotenuse. Thereby I'm also increasing the resistance of the nichrome wire. And so I needed help in order not to destroy or burn out my gear. And fortunately, such help is available online. I choose Arimo, a website which is available in English and German. And here you can select the length and thickness of your wire with a given voltage, and it will tell you the temperature and the current it will induce. And so for my system, I can make good cuts at around 700 degrees Fahrenheit or 450 degrees Celsius, which means at 90 degrees 7.5 volts and at 45 degrees 9 volts. Thereby not exceeding 2.1 amps, which is the absolute limit for my voltage regulator. And all the angles in between have to be balanced out a little bit with the regulator. As said in the beginning, I also included a rip fence to make straight and clean cutting possible. And for this I discovered an aluminum profile idling around. So I made a few cutting tests, and of course it is ideal for that purpose. I cut it to the desired length, added 2 wooden brackets as a mounting aid, and voila, that was easy. Now came the part I really looked forward to, the rotating sled. I have a 50 centimeter clearance between the wire and the cantilever, so that's some room to work with. I cut a groove into the base plate of the sled, which allows a 25 centimeter radius with the table saw. Chiseled off the edge, since the wire can be at an angle, and added a guide pin as a rotating base with a nail. Also made sure that the pin disappears within the plate. That's why I used the drill here, in order to make the head disappear. And then I cut another 1 centimeter groove into the base plate to attach it to the rip fence. Now, since the profile of the aluminum profile has only 1 millimeter thickness and the table saw has a cutting width of 2.5 millimeters, I added a thin insulating tape into the groove. That worked out way better than anticipated, and it makes the handling of the sled very, very smooth. Just the right amount of friction and leeway. Now the aluminium profile is 25 millimeters in height, and the cut in the groove is precisely 10 millimeters, leaving a 15 millimeter clearance. So add some 50 millimeter rails around the sled, and at that point you're pretty much done. And now let's put it to the test for the first time. This is sort of an epic moment because, as you can see, this piece of polystyrol was cut out with a saw or a knife, something very rough, and of course it turned out ugly. So I wanted to see if I could make this a little smoother, even though I have no real purpose for this. This is just a trial version to see what it looks like. Here I cut a little too close to the edge, so I give it a second shot, getting a little deeper into the body of this piece of polystyrol, and this time I made it a very, very smooth turn. And the before and after result, mean, that is stunning. I mean, this is so sweet. It looks like it was manufactured professionally. That is a round edge. Beautiful. And of course I had to put the angle to the test, increase the voltage from 7.5 to 9 volts, fire up the wire, and let's see what comes out with the angle. Beautiful. So of course now I wonder what my first project is going to be, where I'm going to use this thing. But we'll see. Until then, take care, thank you for stopping by, and see you soon. Bye bye.